Hello everyone, my name is Umar. Welcome back to the channel. I hope you guys are doing absolutely fine. In today's video, we're going to talk about persistence in F5. So we are going to discuss about source address persistence and destination address persistence. Before we start, let me walk you through the topology so that we can understand what scenario we have for today's video, and we will define the use cases what we want to implement on our F5 device. And then we'll move ahead with the practical implementation. So in this diagram, you see there is my F5 device. This is my big IP F5 appliance. This is my client side. So let's say I'll just write it. This is my client side and this is my server side. I have set up two virtual servers on this F5 appliance. So I have one virtual server set up for HTTP, that is for port number 80, and I have a second virtual server set up for VS. Another one is for telnet. Okay, so let's say this is VS1 and VS2. Both the servers have an IP address of 68.110.10.99, obviously operating on two different port numbers. So we have a port number 80 for HTTP and we have port number 23 for telnet. Now, in default scenarios, what happens is, now let's say I talk only about the HTTP server. Okay, so let's say this client is going to take HTTP access to my server 1, server 2, and server 3. When the first time the connection is coming onto this particular virtual address 68.110.10.99, big IP will check the connection table. There is no connection. It will establish one connection. It will send it to, let's say, server 1. Here we have set everything to default, so the load balancing method by default is the round robin method. The second connection comes in, big IP will check and it will send it to server 2. The third time a connection comes in, it will send it to server 3, and it will keep on load balancing in a round robin scenario. So this is what is going to happen if we don't set up any external or any extra profiles. Now let's talk about a use case. So what is the use case we're going to talk about? So let me just clear this off. So wait, just sorry. Okay, so let me just clear all of the drawings which I have made over here, then we can define the use case. Okay, so well, now let's talk about the first use case where you are, let's say, shopping. Okay, now if we are talking about a shopping website, so what happens is, just excuse me guys, let me just rearrange this back. Okay, here we go. So let's talk about the first use case where we are talking about a shopping website. So let's say I talk about shopping. Now let's say this particular client, my Windows 7 machine, it establishes a session on the F5 virtual IP address, that is 68.110.10.99, and it will be routed to one of the servers inside. Let's say we are talking about server 1. Now this PC, this client over here, spends some times on the server and then he just goes off. So now when you go to a shopping website, you add things to your cart. So you have your cart in which you have added, like, let's say you have added some 5-6 items. Okay. Now when you disconnect and when you come back, you see that the cart is still there. Now how do we do that? So in that case, what happens is, when the F5 sees the connection coming in, it will go and create a connection in the connection table. Okay, so this is the connection table, let's say. So I have my connection table over here, and it will check, do I have to apply any persistence profile? If I have created a persistence profile, it will apply that persistence profile to the connection over here. So here, this is my source and this is my destination. So this leads us to the first use case which we are going to implement for today, that is source address persistence. Let me just write it down. So source address persistence. Okay. Now in source address persistence, what happens is, the F5 appliance will keep a track about who is coming in. So it will check the source IP address. And once it applies the persistent profile, what it does is, the next time this Windows 7 machine is going to go to this particular address, it will check the source IP address of this particular machine and it will apply the persistence profile, so that every time it comes in, it will be directed to the same server. Now what will happen without persistence? What happens is when this request comes in the next time, so if let's say we have implemented round robin load balancing, the connection will be sent to server 2, and server 2 does not have your cart. So this is not present over here, this is just present on server 1. So obviously for a good user experience, you want your traffic to be going to the same server on which the cart is set up, right? So for that, we implement source address persistence on an F5 appliance, that whenever we come back the next time, we go to the same server and we have our cart ready over there, and we can then check out, buy things, and you can just follow the steps over there. So this is what is about source address persistence. Now the second scenario, so this is the first use case, that is about source address persistence. So before we move on to destination address persistence, let's go and check what is implemented on F5, what is the default traffic behavior, and then implement a profile and then check the difference in the default behavior and once you apply the persistence profile. Okay, so I have, now let me take you to the local traffic. So I'll just show you what all has been configured on this particular F5 appliance. So I have my nodes which are configured. So I have server 1, 2 and 3 on 201, 202 and 203. I have my pools configured. One pool is for HTTP and one pool is for Telnet. And similarly, I have two virtual servers also configured. One is for HTTP and one is for Telnet. So first, let's check the default behavior. So let's do it on, let's say, the Telnet server. Okay, for the Telnet server, so I'll just get up a router over here, the router which we have set up, and it will just take a Telnet access to the virtual address one by one. So telnet 68.110.10.99. Enter. Yes, it's prompting for a username and a password. Okay, so we are in server 3. Let's exit this. So let us establish a telnet once again. Cisco. And yes, we have been directed to server 2. Now let's wait and do a telnet again. Okay, so right now the connection should go to server 1, and yes, this is what is happening over there. So we are going to server 1, 2 and 3. So by default, if I just show you, I'm talking about the telnet server over here. So in the telnet server, so this is my server. We have implemented snat, which we have discussed in the last video. If you haven't seen that, you can just go and check the video out for nat and snat. And now let's go to resources and check. So we don't have any persistence profile over here. So the default persistence profile is none. So we'll just create a source address persistence profile, that whenever it sees one source address, it will create a connection table, and in the connection table it will attach the persistence profile. So next time when I take telnet, my source, until I change my source IP address, the connection will be going on to the same router all the time, the same server. Okay, so to create a profile, let's go to profiles over here. In profiles, let's go to persistence. Now you have the default profiles created for source address and destination address. So we'll keep them as parent profiles, and if you want to manipulate certain values, you can use that, or you can use these profiles as it is. So I'll just go and create one. I'll name it as source address, so SA profile. Okay, and I'll give it a persistence type of source address affinity. If I have to change any parameters, I can click on custom over here and I can match it across services, match it across the virtual servers. So I haven't checked anything. By default, it is not being checked. The timeout is 180 seconds. So I'll just keep it as is and I'll finish it. Okay. Now I have an SA profile created. I will go to the virtual servers and apply that particular profile. So I'll go to the telnet server, and in my resources, I will go and apply a default persistence profile of SA profile which we have just created. Okay, so okay, I just forgot to show you one thing. What is the parent profile for the SA profile which we have created? So let's go and choose that. Yes, source address. Yeah, right here. The source address is my parent profile. Okay, so going back to the virtual servers, let's see if we have done that. Okay, sorry. So the telnet server, And in the telnet server, let's go and click resources. Default persistence profile is my SA profile, and I'll update this. Now I'll go back to my router. Now see, the first time when I establish a connection, it will push me to one of the servers. So I'll just set up a connection. I'll just set up telnet. So telnet, let's see which server we are going to. Yes, we're going to server 2. Now see, how many ever times I do it, it will always push me to server 2. Cisco, server 2, exit. Then again let's say telnet again, Cisco and Cisco, server 2 again. Now I'll just change my IP address over here. So I'll go to this. It's a simple Cisco router which we have used. So int f00 IP address 68.110.10.200 255.255.255.0 exit. Okay, and let's do a telnet again. The telnet, we are going back to server 2. Now it will I forgot to check what my IP address was before, so we'll just go and check that as well first. Okay, so show IP and TBRI. So we have a 200 right now. Let's change it to something else. So let's go back to interface f0/0 IP address 68.110.10.210. Okay, that would be good. 255.255.255.0, the mask of 24. Okay, so once that is done, let's again telnet to 68.110.10.99 Cisco, and here we are at server 1. So now whatever connections are established, they will all go to server 1. Cisco, server 1 again, and again I'll do it just for the sake of verification, Cisco and Cisco. Okay, so that's it. Let's go and check the logs as well. So I'll just go to statistics. I'll go to statistics from here. I'll go to module statistics, local traffic. In local traffic, let me check the persistence records. So here I have created a persistence value for, okay, so that was 200 before also. So for 200, I have being mapped to 202, and for 210 I am mapped to 201, and it is continuously aging. So after 180 seconds of timeout, it will clear this records, and then again we can change the timing. We can just put it to indefinite if you want to be that way. So you can tweak the timers over there. So this was about the source address affinity or source address persistence. Now let me take you back to the diagram there. Let me clear out everything and we will discuss about destination address affinity, destination address persistence. Now why do I use that? So first let's define the use case. Now let's say I am sitting over here on my Windows 7 machine. I establish an HTTP session. So we're just concentrating on the HTTP server. So that is the address 68.110.10.99. So I come into this address for HTTP, and F5 will direct me to, let's say, server 1. Okay. Now I have requested a web page over there. So my server 1 will fetch that web page for me, and it will reply back to my F5, and over here I get it. Now this web page will be cached inside the memory of server 1. Now next time when I go, what will happen? So let me take a different color. Next time if I go again to the same service, F5 will send me to another server there. It will again get that page. It will cache it onto the memory. Okay, again cached, and it will reply back. And again I'll get a reply to my Windows machine. So I'm just contacting this particular IP address. The duty after this is done by the F5 device. Now what is happening? Every time I establish a connection to my F5 device, every time I'm being sent to a new server, the new server is getting the page, it is caching it in the memory. So this is leading to two problems. This is just leading to extra CPU cycles. Okay, and it is just leading to more memory utilization on each and every server over there. What if I just make sure that whenever a request is coming in to 10.99 for a particular web page, this becomes my caching server. Okay, so here I have my caching server over here, and whenever the traffic is coming to 99, it should be sent to this server. So this does not need to cache, nor does this need to be caching all the pages over there. So it will just reduce my CPU utilization on each server, and it will improve my memory utilization as well. So for that particular use case, now it's not a very common use case which you normally see, but in this use case scenario, we want that we want the destination address, if it is there, let's say 68.110.10.99, it should always be sent to this particular server. So whoever is the client, now even if this client is coming, let's say from an IP address, let's say x.x.x.x, or let's say x.x.x.y, or let's say z.z.z.z, that does not really matter. What matters is what destination are they trying to hit. So hence we talk about the destination address persistence. So irrespective of what the source is, here we are just talking about stickiness on the destination IP address. So every time the request will come in, this will be going to server 1 because that is having the cached page. So all the servers don't need to go to some other resource and then get the page over there and then cache it and then reply back to the client over there. So that is the use case which uses destination address persistence. So I hope I have explained this clearly and you have understood what I have explained. Okay. So now let's talk about how do you implement that. Now, so the implementation is simple. The use case is what we want to understand first. The implementation is like, the same way we did the source address profile. So similarly, we have to go back to my local traffic. I'll go to my profiles. In profile, I'll go to persistence. And I'll create a profile for destination address. So DA profile, and a persistence type will be destination address affinity. Parent profile, it has chosen as destination address. The default parameters, I'll retain them as is. If I want to just change, I'll just click on the custom timer over here and I'll say timeout should be indefinite. So there is no timeout for this particular service. And I'll click on finish. Now let me just take you back quickly to the statistics and I'll just show you because the time out must have happened by now. I'll go to local traffic and I'll just check the persistence records. So you see these are empty. The values have timed out. So here in this particular scenario, I have chosen the timeout value to be indefinite. Now I'll go back to local traffic. I'll go back to my virtual servers. Okay, and for HTTP server, let me attach a destination address persistence profile. The default persistence profile, my DA profile, and I'll update this. Okay. Now to verify this, what I will do is I'll go to my client over here and I will access port number 80 on my 68.110.10.99. So well, asking me for a password, Cisco. So server 3. Okay. Now let me refresh this page. Server 3, server 3, server 3. Every time I refresh, it will be going to server 3. Now let me take you back to the F5 and I'll show you the logs, the statistics which we have generated. Let me go to local traffic again and let me show you the persistence records. So it shows me the value 68.110.10.99. We have created a destination address affinity for my pool member 192.168.10.1.203:80. If this pool member goes down, what will happen? If this pool member goes down, so let me just pause this video for a moment. Let me get access to the router over there and just shut it down. Okay, so here we have this server, and what I will do is let's shut this down. So Cisco, let me check which interface we have configured over here. The fast Ethernet 00 interface, yes. Let me go and shut down this interface. So the server automatically goes down. Shut. Okay. Now the server is shut down. It's not available. Now what will happen? Now it will fall back and it will create a mapping for that address. So let me go back to the client and refresh this connection. So we are at server 1. So at load balance, now everything will be at server 1. This is just a fallback scenario which I wanted to show you. Again, let's go back and refresh this entry. So now you see the destination address affinity has been created for 192.168.1.201. That is my server 1's IP address. Okay, so well, this is what I wanted to show you. I hope this has been informative. Before we just sign off, let's summarize what we have done. We have done source address persistence for my, so I'll just take a pen over here. So I have done source address persistence when you are accessing the telnet services. So till the time the client IP is same, it will be sent to one router over here. If the client IP changes, then only it will be sent to another server. So here we have done the stickiness based on the source address. So this is the source address and the stickiness was based on the source address. So if the client IP is same, it will be redirected to the same server again and again. In the second part, we talked about destination address persistence, which does not talk about the client IP addresses here. So whatever the client IP address be, if you are talking to 68.110.10.99, which is your destination, so see, this is the client, or okay, this is the source, and here we are talking about the destination. Okay, and again, this becomes the client here, and it becomes the destination over here. So whoever responds first, that is mapped to this particular server address. So this destination address affinity is attached over here, and every time whoever comes in and accesses this particular address, it will be redirected to the same server unless and until the server goes down. If the server goes down, then only the F5 device will choose a different server based on the load balancing method, and it will then create an affinity for that particular server. So before we just sign out, we'll go and check the persistent profile mapping. So the age is right now 6 seconds. Let me refresh. So it has become 136 seconds. And since I have placed the timeout to be indefinite, it will never time out unless the pool member goes down. I hope this has been informative. Thank you for watching, guys. You can comment down below. Have a nice day. Subscribe to our channel for more videos on networking every Monday and Friday. Thank you for watching, guys. Take care. Bye bye.